So hello everyone, I Raghvendra Singh welcomes you all again in this channel. So actually today we will be discussing again linear algebra, and today date is 26th of Feb. So actually I have discussed almost all topics, but some topics are still remaining, so I decided to why not discuss these some topics also. So right now I think three topics are remaining. First is linear dependency and dependency, and second is vector space, means concept of norm, and Schmidt was mathematician. So I think there's one topic on that. Sorry. So let's start with linear dependence and independence. Linear dependence and independence of vector. Okay, so what is linear independence and dependence of vector? So if I will discuss about concept only, then I can say that if all values of lambda is equal to 0, then we can say then these will be independent. If lambda all values are not equal to 0, then dependent. It's as simple as that. Now let me write the question and the example. We will do on this topic only one question, and you will get the idea very simply. So we have to check test linear dependency and find the relationship between find the relationship if it exists for x1 1 comma 2 comma 3 x2 3 comma minus 2 comma 1 x3 1 comma minus 6 comma 5. Okay, so there was something which we have given. Okay, so let's discuss the linear dependency. First of all, we will let here lambda, let 3 lambdas whose are scalar, suppose lambda 1 and lambda 2 and lambda 3. Okay, so we have given these x1, x2, x3. So we can also write multiply by lambda x1 plus lambda x2, lambda 1 x1 plus lambda 2 x2 plus lambda 3 x3. Okay, so lambda 1 into x1 is 1 comma 2 comma 3 plus lambda 2 x2 is 3 minus 2 1 3 minus 2 1, and x3 is lambda 3 x3 is 1 minus 6 5, 1 minus 6 and 5. Yeah, simply now we can multiply by lambda, like lambda 1 plus 3 lambda 2 plus lambda 3. So just similarly what I am doing, simple, like lambda 1 from this, then lambda 2, then lambda 3, again 2 lambda 1 plus minus 2 lambda 2 minus 6 lambda 3. Simple. Okay, so lambda 1 plus 3 lambda 2 plus lambda 3 equal to 0, and 2 lambda 1 minus 2 lambda 2 minus 6 lambda 3 is equal to 0, and 3 lambda 1 plus lambda 2 and plus 5 lambda 3 is equal to 0. So we have these three equations. Okay, so now what we will do, like we will write it in the matrix form. These numbers we will write in matrix form, and we will write it in augmented forms. So basically I can write this 1 3 1 1 3 1 2 minus 2 minus 6 2 minus 2 minus 6 3 1 5 3 1 5 lambda 1 lambda 2 lambda 3. Oh no, my battery is discharged. So here is 0 0 0 division equal. Okay, so now I will write it in augmented forms. In augmented forms, basically we have 3 1 3 1 2 minus 2 minus 6 3 1 5 and 0 0 0 also. Okay, so basically I have converted this into A is to B. C is equal to A is to B. This is R, but B. We let it in. This is A, and this is lambda, and this is B. So now we will use operations. Operations which type of, like for this we have to convert it this 0, and then this we have to convert it this triangle in 0 0. So what can I do in operations? I can do operation in R2 to R1 minus R2. I can do this, right? In R2 I can do R2 minus 2R1. Okay, and what in R3? Simply R3 minus 3R1 3R1, yeah, R3 minus 3R1. In R3 I can do R3 minus 3R1. Okay, yeah, so simple. Now I will do this. Okay, so now let me apply the operation. So first row will be as it is, 1 3 1 and 0. Now second row, R2 2 minus 1 0 minus 2 minus 6 minus 2 minus 6 minus 8 minus 6 minus 2 minus 10, sorry, minus 6 minus 6 minus 2 minus 8, and 0 minus 0, again 0 as it is, and R3, this R3 minus 3R1, 3 minus 3 0, and 1 minus 9 minus 8, and 5 minus 3, 5 minus 5 minus 3 is 2, again 0 minus 0, 0 as it is. Okay, so again we have to make it 0 again, because we need to 0 in triangle. So we will again use the operation. We will use operation now in R3. What we will do, we can simply add R1, R2, R3 plus R2. Simply minus 8 minus R3 minus R2, minus 8 minus minus 8, minus 8 plus 8, 0. Simply, so this will be 0. Let me go on next page. So simply our first row and second row will be as it is, that is 1 3 1 0, and 0 minus 8 0, and now this row will be changed. Here will be 0 0 and 10. It will be 0. So now this is perfect example. Now I can write lambda 1, lambda 2, lambda 3. So from here onwards, this multiplied by this means lambda 1 plus 3 lambda 2 plus lambda 3 is equal to 0, minus 8 lambda 1 minus 8 lambda 2, sorry, this is lambda 2 because here is 0, so 0 lambda 1 will be 0, so minus 8 lambda 1, 8 lambda 2 minus 8 lambda 3 is equal to 0, and 10 lambda 3 is equal to 0. So from here onwards we can see that all values lambda 3 is equal to 0 we can see, and lambda 1, lambda 3 is 0, then we will put here 0, and lambda 2 is also 0, and lambda 3 is also 0. So as we know the condition of independency, that if all lambda's value is 0, as I've written here now, if all lambda's value is 0, then we can say it is independent. It is independent. Okay, so this was very simple concept of dependency and independency. So now we will move forward. It is independent of a given data. So forward, now we will study about inner product spaces. Inner product spaces, basically it is nothing but the dot product. I don't know what to say, but it is similar to dot product, similar to dot product. We all know what is dot product. We have done in the preparation of IIT JEE and 12th class also in the vector 3D chapter. So basically it is similar to dot product. If you know dot product, then we can easily understand this concept. So basically here one concept comes, that is norm. Remember this, there was norm. I think this word you will be hearing first time. Basically norm is nothing but kind of magnitude, kind of magnitude. Basically what was magnitude? If we have given 1, 2, 3, then this is equal to suppose u, then what will be magnitude of this? This will be root of 1 square plus 2 square plus 3 square is equal to 9 plus 4, 13 plus 15. This will be total 15. 14. So basically this is something which we were used to do in our 12th class or IDG preparation. So now what is norm? Basically norm we use here one mode, here will be double mode. This is u, so this is called norm. This is called norm. Basically we will do same thing. Like if someone said find the norm of u, this will be given, then simply 1 square 1 stage, then 4 plus 9 13 14, answer will be 14. But the word is changed, we say here this is norm. Okay, so I have told you the concept behind this. Okay, so let's let me just say something. So we know that if this will be given u is equal to u1 and u2 and u3, and v is equal to v1 v2 v3. So what will be u in u dot v? So basically simply we have to do dot product u1 into v1 plus u2 into v2 plus u3 into v3. It's very simple. Okay, so now one more thing, that angle between two vectors. So we know in our 12th class or ITG preparation we use that angle means cos theta is equal to a vector dot b vector upon mod of ab. We are used to do this now, like cos theta is equal to a vector dot b vector upon mod of ab. We were used to do this, right? Yeah. So basically the same concept also apply here. Suppose we have given in place of AB, we have given u vector dot v vector, then is equal to norm of u dot norm of v. Okay, norm of u and norm of v into cos theta. So basically what will be cos theta? So u dot v upon norm of u into norm of v is equal to cos theta. Okay, so it is as simple as that. Now we will do one question on it. So now we will do question on it. Question example is, suppose we have to, one more thing that I need to explain to you, that is, what is this? This is Cauchy-Schwarz. I'm not sure with the spelling, you can check on internet. Inequality. So Cauchy-Schwarz inequality. Actually what this statement says, that magnitude of u dot v will be less than equal to norm of u dot norm of v. It's very simple. Okay, so now we will do question. Simple. Dot product of u and v will be always less than or equal to norm of u and dot norm of v. Example, we have verify Cauchy-Schwarz inequality, Cauchy-Schwarz inequality for the given vector. So basically u is equal to -4, 2, 1, and v is equal to 8 minus 4 comma minus 2. Okay, so this will be here. So what is Cauchy-Schwarz law? U vector u dot v will be always less than norm of u dot norm of v. So first of all we will calculate norm of u. Although I have written here norm, so I do not need to write this, but I'm writing because of habit. Okay, so how can we calculate norm of u? Simply we have given u the magnitude kind of, so minus 4 square plus 2 square plus 1 square. Okay, so here will be 16 plus 4 plus 1. 16 plus 4 20 plus 1 root of 21. Okay, and now norm of v. What is v here? 8 minus 4 and minus 2. So simply minus 8 square plus, sorry, not minus 8, plus minus 4 square plus minus 2 square. So what will be here? 64 plus 16 plus 4. 16 plus 4 is 20. 60 plus 20, 80, and 84. This will be root of 84. Now we have to do u dot v, basically simply dot product. So minus 4 and minus 4 into 8 minus 32 plus 4 2s are 8, minus 4 into 2 means minus 8, and minus 2 into 1, so minus 2. So here will be minus 42, right? Minus 42. So remember we have to find u dot v, means mod of u dot v, so it will be 42 only. And now we have, now simply what was inequality? It was u dot v less than equal to norm of u into dot product of norm of v. So what is u? It is 42, and less than equal to what is norm of u? Norm of u is root 21. What is norm of u? It is into root of 84. So we can also write root of 84, that root of 84 we can write 2 root 21, right? 2 root of 4 into 21, 21 4 is 84. So 2 into root of 21, so 22 into root 21 into root 21, 2 into root 21 into root 21. So root will cancel, then 2 into 21, 2 into 21 is equal to 42. So similarly 42 is less than equal to 42. So hence it's true, right? So we can say Cauchy-Schwarz inequality applies. So it applies. It's very simple, right? Yeah. So now we will move forward. Next page or the same page. Now one question we will be given like this type of, what can it say? Suppose one question, I'm not discussing the complete. Simply we will be given two vectors u and v. We will be given two vectors u and v, and said to be orthogonal. Only if u dot v is equal to 0. We know we have a property that if it is orthogonal means perpendicular, right? So it has to be equal to 0, and we will given what is u minus 2, 3 and 4, and v is equal to 2, 4 and minus 2, 2, 4 and minus 2. So 2, 4 and minus 2, this will be also given. 2, 4 and minus 2. Yeah. So basically, if this is orthogonal, then this value should be equal to 0. So minus 2 into minus 2, minus 4, 3 into 4 plus 12, 4 into minus 2, minus 6, minus 8. So minus 4 minus 8 minus 12 plus 12 is equal to 0. So we can say this is orthogonal. It is. Okay. Now we move forward. That is sorry, that is Gram-Schmidt process. He was mathematician. Gram-Schmidt process. Okay. So what he says. So he says, basically we don't not need to know what he says. Simply we have to follow some steps. That is, so we will be given u1 and u2. We will be given this will be given always. So some steps. Step first is always v1 is equal to u1. Okay, if we will be always given u1, then we will let that it is equal to v1. And step 2 is v2. Step 2 is v2 is equal to u2 minus projection of v2. Okay, projection of v2. So not v2, it is projection of u2. Projection of u. This is u2. So what does it mean by projection? Projection means that u2 dot v1, this is dot product, and norm of v1 square, outside also v1 only. Okay, the step 2. And step 3 is step third is orthogonal basis. Let me check my battery. How much is this remaining? So orthogonal basis. Third step is q1 v1 upon norm of v1. Simply q2 is equal to v2 upon norm of v2. And now it is self understood that q3 is equal to v3 upon norm of v3. Now let's do the question on it. Question will be something like this. Battery is very discharged. So question is, sorry, it is not orthogonal, it is orthonormal. So orthonormal. Okay, got it. Not orthogonal, it is orthonormal. And here is also orthonormal. Basically we have habit to say orthogonal. So I have written here, it is orthonormal. Remember it. So question is, find the orthogonal basis for the subspaces of R3. Find the orthonormal process. Orthonormal basis for the subspaces of R3. For the subspaces of R3 for the subspaces of R cube by applying Gram-Schmidt by applying Gram-Schmidt process where S is equal to 1, 2, 0. Suppose this is U1 and U2 is 0, 3, 1. 0, 3, 1. Okay, 0, 3, 1. This is U2. So simply first step is we have given U1, U2, as I have said that this will be always given. So first is I am just writing everything. Step first, what he says that V1 is equal to U1 always. Means from here onwards we get V1, that is 1, 2, 0. Now what step 2 says? Step second says what he says? He says that V2 is equal to U2 minus projection of U2. And I have already told you that what does it mean, projection of U2? Projection of U2 means this. Okay, dot product of U2 into V1, then outside V1 and norm of V1 square. So I can do this here, yeah? So basically what will be U2 into U1, U2 into V1. What is U2? This is U2 and this is V1. So 0 into 1, it will be 0 as this. And 3 into 2, it will be 6. 1 into 0, it will be 1, it will be 0. So this is coming 6. U dot V is coming 6. Okay. And what will be here? So what will be here? What second step? So basically we have to find here right now. According to this, we will put everything. So we were finding step 2. We were finding. So V2 is equal to U2 minus projection of U2. U2 minus projection of U2. Projection of U2 is, can also write U2 into V1 as it is upon norm of V1. So we have finded this, that is 6, and V1 we have, what is V1? 1, 2, 0. 1, 2, 0. Okay, so V2 is equal to, what is U2? U2 is 1, this is U2, this is U2. This is U2, 1, 0, 3, 1. U2 0, 3, 1 minus, we have calculated this, U2 dot V1, it is 6 into, what is V1? v1 is 1 comma 2 comma 0, 1 comma 2 comma 0, and what will be this? This will be norm of v1. What does it mean, norm of v1? We have v1 this 1 comma 2 comma 0, so basically 1 square plus 2 square, so it is 5, root of 5. So simply v2 is equal to 0 comma 3 comma 1 minus 6 will go inside, means this is root 5, so 6 upon root 5 comma 12 upon root 5 comma 0, 12 upon root 5 comma 0. Root 5 comma 0. Okay, so basically this will be here. Yeah, so now we will minus it, like 0 minus 6 root 5, so v2 is equal to 0 minus 6 root 5 minus 6 upon root 5 as it is. Okay, 6 upon root 5 as it is. Oh, 1 second, sorry. Like here, what is this? Is square, norm of v1 square. So what will be here? This is norm of v1 square means root 5 square. It will be 5 as only, 5 only. So 6 upon root 5, 6 upon 5 comma 12 upon 3 minus 12 upon 5. So what will be here? 3 minus 12 upon 5. So 15 minus 12, 3 upon 5. So 3 upon 5 comma 1 minus 0, it will be 1 as it is. So what is this? Is v2 finally. That was v2. Got it? And now step 3 comes. Step 3. What it says that if we have to calculate q1, then we have to calculate v1, norm of v1, and q2 then v2 upon norm of v2. Similarly with q3, v3 upon norm of v3. Okay, so simply we'll go with q1, u1 upon dash of u1. So basically what was u1? So should I write it again? u1 was this 1 comma 2 comma 0. So 1 comma 2 comma 0, so 1 comma 2 comma 0 upon norm of this, means norm of this means, again here there is a square, and there is a square. So norm of this means root 5 square, that is root 5 square, that is 5 again. And similarly with q2 we have q2 this minus 6 upon 5, 3 upon 5, 1 upon that is v2, and we have to calculate norm of v2. Then what will be this? Minus 6 square means 36 upon 25, comma 9 upon 25 comma 1, 9 upon 25 comma 1. So square root of this, sorry, there was plus, so 36 plus 9, 36 plus 9 means 45, right? 45 plus 25 is 50 and 70, so 70 square root of 70 upon 25. So I can also write it root of 70 upon 5, right? So we are finding q2. Till q2 5 will go up, because we know that the concept behind this, that is u1, if here will be u upon v and a upon b, and this will multiply from this and this will multiply from this. So same thing I am doing here. So minus 6 upon 5 into 5, it will be minus 6, comma 3 upon 5 into 5, it will be 3, 1 upon 5. Okay, so now we will write root 70 here, or I can write q2 is equal to minus 6 upon root 70, comma 3 upon root 70, comma 1 upon 5. Sorry, here is 5 only. 1 into 5, 5 upon root 70, 5 upon root 70. So this is q2. This is q2. Okay, so basically here I can also solve q1 further. That q1 I can write 1 upon 5, 2 upon 5 and 0. My battery is very low, so I have to finish very quickly. So same thing we can do with q3. What in q3? Simply q3 means v3 upon norm of v3 square. For this we have to calculate v3. Here we don't need to find q3. If we have to find, then here's one condition, that is for v3, simply for v3 we have to do v3 is equal to u3 minus projection of v3. What does it mean, projection of v3? Simply v3 is equal to u3 minus projection of v3. Projection of v3 means dot product of u3. Projection of v3 means dot product of u3 into v1 upon norm of v1 square dot v1 minus okay, and u3 dot v2 upon, and this will be v2 upon norm of v2 square. So this is the process to find v3. Then simply we can find q3. So okay, I hope you have understood everything. These were some topics which were remaining. So now I have solved everything. So thanks for watching. Almost linear algebra. Algebra is finished.